Hey folks, welcome back. We're getting ready to crush the exam, talking about exam 3, and here we have a frame problem. So in our physical system, this is the scenario. We have this frame. We are told that bar AB has a clockwise rotation of 4 radians per second, and we are asked to find the angular velocity and acceleration for components, bars BD and DE. And I am going to do this problem the easy way, but first I invite you to do the problem, pause the video, do the problem, and then I'm going to show you it's a way that's talked about in the book, but I'm going to how it works, and maybe it'll be a little easier. The steps are all the same, it's just a little bit of conceptual difference. But at any rate, now is your opportunity to pause. Okay, all right, so as promised, we're going to do this a little bit differently. I have taken the liberty of drawing the vectors for what the book calls the vector method. It is actually not a thing, but it does kind of make things easier. So the vector method is this. So essentially, in order to solve this, we know the rotation of member AB. We can use that to get velocity B. Then we can come at the velocity of D from 2 different directions, which will allow us to solve for the components. That involves all the same steps as doing this, right? So the acceleration, the velocity, or I guess, how would we say this? We would say the velocity of D is equal to the velocity of B plus the velocity of D with respect to B. Now, notice from the geometry that this comes from, we could say from E, right? And the formula for this is omega dE cross with RD, right? That's what I'm calling it here. It's just that, cross with RD, is equal to, and this comes from A, right, as shown here. And what is that? That is omega AB crossed with RB, right, plus this is, obviously this is from B, right? So from B, right? And what is that? That is omega BD crossed with RDB, right? So the angular velocity of this component crossed with the the position vector from B to D. Because recall, the position vector can be anywhere on there. So, all right. So that is the vector method, and note that solving for VB first is just doing this part first, right? And that is exactly what we would do here, right? So we can do this stepwise, or we can throw it all together. I think it's a little bit easier if we do this part first because we have a number for omega AB. So let's we'll just number these as we go, right? So we'll call this step 1 here. Okay, and so step 1 VB is equal to, well, actually, you know what, let's make a note to ourselves in case we want to use this for study. So find VB. Okay, so VB is equal to omega AB crossed with RB. The cross is on purpose. And by the way, notice that when I start, I leave a note to myself and I write the formula. Super important. Always do that. You will get it right way more often. So let's see, what is this? This is 4, and that is in the clockwise direction, so that is a negative. So minus 4, and this is K, crossed, and RB is minus 7I, okay, and K cross I is positive J, and negative times a negative is a positive, so VB is equal to 28J. And note, that just goes there, right? So which one do we want to do next? I don't care. I don't know. It's a heads or tails kind of thing. Let's go here because the more I write, the harder it is to write a 2 right there. That is literally how I'm making that decision. That's terrible. I should be more rigorous. I should be a better engineer. Okay, so let's see. 2. What do we want? We want to find... And actually, you know what? I wonder if we could just put it all together. We probably can, but it might be a lot to write. Yeah, that's fine. We'll do this. So this is from E, right? So let's see, find V, is that D? Yeah, find V sub D, okay. And V sub D is equal to omega dE cross with R sub D, right? And that equals omega dE. Okay, and by the way, the sign matters here. Well, it doesn't. It doesn't. I prefer to put the sign there. It makes no difference. Just leave it the way it is. You could, I guess, is where I'm going with that. And if you want to talk to me about it, that's fine. But let's see. This is K. In this case, we're crossing with, this is minus 8J. So K cross with J. So by the way to think about these, if you want to know if it's positive or negative, check this out. I cross J. Okay. J cross K. K cross I. Right? Note, I, J, K, and then when it loops it back around, these are all positive. Right? So if it's going forward, or, you know, in the case of K, looping around, it's positive, otherwise it's negative. That's the easy way of remembering that. So let's see. This is just, it's Kj, so it's negative, so this is a positive, right? So V sub D is, V sub D is from E. This is the wrong one. Uh-oh. That is not true. Hold on. Let's do this right. Let's see. So from here, this is minus 11 plus 3, right? So minus 11I plus 3J. All right. Okay. So that equals, I do the J first because I want to end with J I and j. So let's see. K cross j is minus I, so this is minus 3 omega dE. And then k cross I is positive, so it's negative, so minus 11 omega dE, and this is j. This, I really need that to be in there, so that's I. Okay, and this is v sub d. Alright. That's so funny. I was just about to make a comment about, you know what, I probably would have gotten that right if I wouldn't have been talking. And then I realized what that would sound like. Oh, that's terrible. Okay, so let's see, 3, what do we want? Now we want the third piece, right? So 3, that guy there. Alright, so what are we doing? We're finding VD with respect to B, right? So the rotational component. Alright, so VDB, what is this equal to? This is equal to omega BD cross RD with respect to B. Or, yeah. So, let's see. Omega BD crossed. And now we're at the minus 8. This is K. Wow, that's terrible. Let me start that over. Omega BD. So this is a K. We're going to cross that with minus 8J, right? And KJ is minus, so BD with respect to B is equal to 8 omega BD in the I direction, right? I got that right? I think I got that right. And yeah. All right. So now what we can do is we can just plug these in, right? Okay. Well, let's see. So we'll say 4. What do we call this step? Well, let's see. Let's give this. All right. We'll give this a number. All right. There we go. And we'll say compile. And let's call that equation 1. All right, so number 2 is this, so minus 3 omega dE in the I direction minus 11 omega dE in the j direction equals 1 is 28j plus 3 is 8 omega BD in the I direction. Alright, so looks like if we try to solve in the I direction, we have one equation, 2 unknowns, and if we try to solve in the j direction, then we have one equation. So let's see. I guess that gives us a new step, doesn't it? Alright, so step 5. Say we'll consider IJ. Actually, it's not considering, it's equating. There we go. Equate IJ coefficients. CI. There we go. All right, so j direction? Sure. So in the j direction, what do we have? We have minus 11 omega dE equals 28. All right, well, that leads me to believe that omega dE is some sort of a negative number around 2 something, right? Turns out that it is 2.545, and there we go. Yep, and it is moving in this direction. Right, it's negative. So we'll say negative for now because we'll end up using that. And let's see if that makes sense. So if it's negative, that means it's moving in the clockwise direction, right? So let's see. This is clockwise and there, so no, that can't be true. Let's find out. So minus 11. Not sure how that ended up being there. I'll come back to that. In the I direction, I'm looking. I apologize. I'm looking for the problem with it, because the direction is positive. So let's see if it's here. This guy, kj is negative. Okay, omega dE is positive, so VD is negative 11, 28, this is JJ. I have no idea. That's bugging me. It's pulling it up, so that's going in the counterclockwise direction. So I'm not sure. Hang on. I'm not comfortable with not knowing. That's bugging me. Oh, that's funny. There isn't actually anything wrong. It is rotating in that direction. Silly. Alright. Okay. Well, I'm going to keep going with it. Okay, so that gives us this value. Okay, and in the I direction, Okay, we have minus 3 omega dE. Well, we know what that is now, right? That is minus 2.545. Okay, and that's going to be equal to omega BD. So negative, negative, positive. So this is 3/8 of this guy. So that gives us that, wait, yeah, omega BD is equal to 0.955 radians per second. So that is going to be that way. So let's see, does that make sense? If we're pulling up, then that means that this guy, so this guy is going that way, this guy is going this way, which means that this guy is going this way. Yep, that makes sense. Negative, positive, negative. Right? Okay, makes sense to me. Cool. All right, so now the accelerations. And again, we can use this sort of a strategy, right? So recall. Actually, you know what? The only thing we need to recall is that the relative acceleration is the same, right? So AD equals AB plus AD with respect to B, right? And for each of these, let's just put them together. So let's say put that there, and hopefully we won't have to erase anything. So 6. We'll just, what are we going to do here? Let's find an equation for each term of this. And we'll call this equation 2. Find an equation for each term in equation 2. So A sub D, so remember this is from frame E, so A sub D is equal to what? That is equal to the normal and tangential components, right? So alpha dE crossed with RD minus omega squared dE times R sub D, right? And that is, let's see, we don't have this, but we do have that, this cross product, right? So alpha dE in the k direction crossed with, this is minus 11I plus 3j. That's going to be minus, and then omega squared dE. Let's just calculate that real quick. 2.545 squared is 6.477. So that's going to be times minus 11I plus 3j. Okay, and when I put this together, what I'm gonna do is I'm gonna compile it in I and j directions, because look, I'm gonna have a component I and j and a component I and j, and then I'll just put them together. So when I do that, I get 71.247 minus 3 times alpha dE in the I direction, plus, both of these are going to be negative, but I didn't want to mess with that, so minus 19.431 minus 11 alpha dE, and that's in the J direction. Okay, so then A sub B is equal to, same thing, right? Alpha, in this case AB, crossed with RB, minus omega AB squared times RB, and we were given that there's just an omega AB, so that implies no angular acceleration. So then this is minus omega AB squared. So let's see, omega AB is 4, so 16 times 7, it's minus 16 times minus 7, so 16 times 7 is what? That is 112. So this equals 112, and that is in the I direction. Okay. And finally, A D with respect to, is it B? No, it's B, isn't it? Yeah. So D with respect to B is same thing, right? So alpha cross, or alpha BD crossed with RDB minus omega squared BD times RDB. Okay, and D with respect to B is just minus J, so what is this? This is alpha, this is K crossed minus J, which is I, right? So that is equal to 8 alpha BD in the I direction, right? So positive times a negative KJ gives us positive I minus, and then see, it's minus, but this is then going to end up being a plus, so omega BD squared is 0.955 squared times 8. And that gives us plus 7.296, and that is in the J direction. Okay, so again, we have these components, and since we're running out of space a little bit, let's do them. We'll just preemptively break them up into their components, right? So A sub D, the I component of it is this guy here, so let's say 7, solve, close enough. All right, so we have I direction, that gives us 71.247 minus 3 alpha DE. I guess I should have looked to see, wait, there's, let's do the J direction first, because there's an I here that has something attached to it, so we're going to end up with one equation and two unknowns. Here we are, J direction, and this is minus 19.431 minus 11 alpha DE is equal to AB plus ADE. So AB is I, so that's 0, equals 7.296. So what do we got here? We got 7 plus 19.431 divided by 11. And when we do that, this gives us that alpha DE is equal to minus 2.43 radians per second squared. Similarly, we're going to do the I direction. That gives us 71.247 minus 3 times this, minus 2.43 equals, A sub B is 112, and A sub D sub B is plus 8 alpha BD. So we rearrange it, and when we do that, it gives us that alpha BD is equal to minus 4.05 radians per second squared. So now I was talking the entire time, and I sought to consider, and still the problem took me a while to get through. So practice, 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 and keep in mind that you're definitely going to see a problem like this on the exam, and being clear on how to work through this is critical. And also consider that I definitely won't give you a problem like this on the exam because it just takes too long, but I may give you a problem like this in 2 parts, right? So maybe first half you find the omegas, second half you find the alphas, or something. At any rate, I hope this was helpful. I hope this video helps you to conquer the exam, and I will see you in the next one.